Okay, so this is going to be my demo. This is my final project for my course. It was take 6 things that we didn't learn in class and implement them into a project. So the first thing that I did is these shadows. So I'm shadow mapping using a depth buffer from a frame buffer object. So I move, well, essentially I take the light matrix. So I render the scene from the view of the light in orthographic, and then I use that depth to map out where the shadows are going to be. And then essentially, if the pixel, when it's drawing later on, if the pixel is visible from the light perspective, then it draws it with its normal color and its normal lighting. And if it's not visible, then it doesn't use the lighting calculation. So that's why it's darker. And then the second thing was those particles. So these are instance particles. So that's 1,000 particles right there. I'm drawing, and it's not causing any issues. It's another 1,000 there. If I keep going through these trees, then each tree has 1,000. Like each emitter has 1,000 particles. So once I get through all the trees, then there's 11,000 particles on the screen. Another thing I did was height mapping. So this terrain is height mapped using a texture. So it's just a black and white texture, and then I take the color value and offset the Y of the pixel based on the color value, multiplied by a certain amount to get higher or lower values. And then the water here, I use the same height mapping texture, but I offset the UV coordinates to get a different sort of feel. So I pass in a value. It's set on a timer, so the timer goes from -5 seconds to 5 seconds, and it keeps iterating through that, and it'll start over after it gets to 5 seconds. So essentially what it's doing is it's offsetting that pixel's height value is by offsetting the UV coming in from that texture. So instead of being where it's supposed to be, it'll offset it by between -5 and 5. So it'll get a different value. That's why it's constantly moving. It never stops moving. And then another thing that I did was, so that's the water, the height map, the particles, the shadows. So the particles actually leave shadows as well. So another thing I did was cell shading. So this tree, as you can see, has cell shading on it. It's the top layer is the brightest, and then it goes down to the next layer, which is slightly dimmer, and then the next layer is slightly dimmer. There should be 6 layers to this. It's just going to be hard to see. Yeah, it's really hard to see the topmost layer. It's not very different. Okay, so there we go. You can barely see the dark. The difference between the dark, the orange, the last orange, and the black color. There's like a brown, really dark color in there. So there's 6 different layers of color. So that's all done in my fragment shader lighting calculations. Oh, right. And then there's one last thing that I did just for kind of fun. So I run into that, and then it shakes the camera, and then it'll screw up your view. So it sets it kind of disorientingly to something that it wasn't at before. Yeah, that's all the things that I did. Oh, fog, right. Fog. So I did not use the OpenGL fog calculation, like fixed function fog. I used a density and gradient variable in the vertex shader, to determine essentially what the color would be by distance from camera of the pixel, so that based on how far the camera is away, the farther I get away from a pixel, the more gray it will be. The closer I get, the more natural color it will be. So now that I'm fully close to the ship, there's no gray whatsoever, and same with the ground and these trees here. But I get farther and farther away, and the ones in the background, you can kind of see the purple one in the back, or the orange one in the back left there. It's kind of gray, and the closer I get, it kind of cleans up, and then yeah, it'll be based on distance, so the ones in the back will gray out first more than the ones forward. And that's my demo.